everyone! Today's video introduces the concepts of pitch and frequency and how we analyze these acoustic properties using spectrograms. Here at the DSEC Lab, one type of data that we collect from participants in our studies is auditory data, meaning the acoustic characteristics of our participants' speech. If you've participated in one of our studies before, this could be your speech data. Why do we care about looking at speech data? It contains a lot of information about acoustic nonverbal cues, that is, nonverbal cues that we perceive through listening with our ears, such as pitch, intensity, and speech rate. This video will focus on pitch, which describes the highness or the lowness of our voice. We can vary the pitch that we use for a variety of purposes. You may have noticed that your pitch goes up at the end of a sentence when you're asking a question or when you want to emphasize certain words in a sentence. We also vary our pitch depending on the emotion we're expressing. For example, we use a higher pitch to vocally express happiness and anger, and a lower pitch to express sadness. At the DSEC Lab, we use a speech analysis software called PRAT to analyze speech data. Let's look at an example sentence. Let's talk about it. In the first window, let's talk about it is represented as a waveform. The height of the waves tell us the intensity of the sound, or in other words, how loud the sound is. The taller the waveform, the louder the sound. In the window below, let's talk about it is represented as a spectrogram. When we speak, the vibration and tightness of our vocal cords creates different frequencies. Frequency, which is measured in units of hertz, is often used interchangeably with pitch. A high-frequency sound, which requires tightened and rapidly vibrating vocal cords, will sound high-pitched, and a low-frequency sound, which uses less tightened and less rapidly vibrating vocal cords, will sound low-pitched. Try making differently pitched sounds while holding your throat. Do you notice a difference? Our ears are able to pick up on different frequencies. Spectrograms are very informative visual displays since they mimic the analysis that our ears do for us when they hear a sound and parse through all the different frequencies. To get a sound spectrogram, slices are taken from the waveform, rotated and stacked to create a 3D display. The three dimensions of the spectrogram are time on the horizontal axis, frequency on the vertical axis, and amplitude in the grayscale. You might notice that the dark gray areas of the spectrogram correspond to taller spikes in the waveform. That's because the darker areas correspond to sounds with greater amplitude. In other words, sounds that are louder will appear darker. For instance, this dark patch here tells us that this specific speech segment is louder at this specific frequency, as compared to this sound here, which is not as loud at this specific frequency. Our lab often looks at these data to understand how people express emotions through their voice. Differences in the pitch and intensity of their voice can give us clues about a speaker's emotional intent. We hope you enjoyed this introduction to pitch and spectrograms, and thanks for tuning in.